So our last 5 problems, numbers looks like 10 through 14, deals with the dividing monomials. And remember what our dividing rule is that if we're dividing with the same base, we keep that base and we subtract the exponent. And why would that be? Because think about that as if we have a to the 4th divided by a squared. If I have 4 a's on top and I have 2 a's on bottom, anything divided by itself becomes 1, cancels out. So I cancel and I see my answer there would just be a times a, which is a squared. We don't want to have to write the expanded notation, so our shortcut is let's keep that base, let's subtract the 4 minus 2, and let's get our answer. So as I come down to number 10, when I'm doing 2 to the 3rd divided by 2 to the 8th, I see that I'm going to do 2 to the 3 minus 8, which is 2 to the negative 5th. But we know we're not going to leave our exponent with a negative, so I'm going to write it as 1 over the same base to the positive exponent. However you remember to reduce that negative exponent, whether it's cross the line, change the sign, or take it to the denominator, make it positive, our answer for number 10, 1 over 2 to the 5th power. Now notice I didn't evaluate that. It says to write, the directions tell you to simplify each exponent with a final answer that's positive. It does not tell you to evaluate that. So if you did 1 over 32, you may have lost a point or two on it. Make sure you write it in the proper form. As I look at this one, I have 20 a's on top and I have 4 a's on bottom. One of the ways you may have heard say it is, where are there more a's? And wherever there's more a's, that's where your variable goes. I should say x's. There are more x's on top than on bottom, and there are 16 more. Are there more y's on top or bottom? There's more y's on bottom, and there's 1 more y on the bottom. So that might be a way that you've thought about it. Or we can traditionally say this is x to the 20 minus 4, which gives me x to the 16th, and y to the 2 minus 3, which would give me x to the 16th, y to the negative 1st, and then we rewrite that as our simplified answer of x to the 16th over y. We typically don't write exponents or coefficients of 1 when they're there. That's not completely simplified. So notice I didn't write that y to the 1st power. Good habit to avoid is getting rid of that exponents and coefficients of 1. So I look at this one, it's still a division problem. I still do 18 divided by 6, m to the 7th divided by m squared. I'm going to do m to the 7 minus 2. Gives me my answer of 3m to the 5th power. As I look at number 13, still dividing, negative 28 divided by 2. My coefficients still do the division here. Negative 14, p to the 7th divided by p to the 16th. P to the 7 minus 16 would be negative 14, p to the negative 9th. That negative 14 is fine. We don't move negative numbers, we move negative exponents. So this exponent right here needs to go to the other part of the fraction, which gives me my answer of negative 14 over p to the positive 9th. It went down to the denominator and we made it positive. You also, like I said, may think, where are there more p's on top or bottom? There's 7 p's on top, there's 16 p's on bottom, there are 9 more p's down here than up here. However you can get that correct answer is what we're shooting for. And last but not least, we're going to reduce 24 over 10. We're going to divide both top and bottom by 2. I know dividing fractions may throw us off, or simplifying fractions may throw us off sometimes, but I get 12 over 5 as my answer. And then there's a few ways we can attack these a's, but notice I'm looking at it a piece at a time. I'm saying, okay, let's do our coefficient. Now let's do our a's. I might think a to the negative 2 minus 2, dividing with the same base, keep the base, subtract your exponent, would be a to the negative 4th, and that negative exponent means my a to the 4th goes in my denominator. And then I might think, well, my b's are going to be to the 8 minus negative 3. 8 minus negative 3, keep, change, would be b to the 11th. A lot of people put 5 on that one. Make sure you recognize we're not doing 8 minus 3, we're doing 8 minus negative 3. We're subtracting that and that to see a positive exponent. My b to the 11th goes on top. There are other ways we may attack this problem. I'm going to kind of leave it as that right now, but you may have thought, well, let's clean up that negative exponent by moving those up here. and having my b to the third up top with my b to the 8. And let's move those a to the negative 2 down here to have my a squared down with that a squared to give me my a to the fourth. So there's a few thought processes that you can do to apply that. You just got to make sure that you're comfortable with one of them and can consistently get those correct. If you have questions, make sure you hunt your teacher down. I hope you guys have a wonderful day.